Good day, Earth Science students. Welcome to Video Lecture, Episode 8. Today we're going to start in Section 3 of Chapter 15. So we're in the last section of Chapter 15, and remember Chapter 15 is dealing with the atmosphere. So let's look at the main ideas on slide 105, the main ideas of Section 3 of Chapter 15. The bigger topic is air movement, and under that we're going to talk about forming wind, global winds, and local wind systems. Now let's talk about the objectives for this section. Objective 1 is explain why different latitudes on Earth receive different amounts of solar energy. Objective 2, describe the Coriolis Effect. And Objective 3, locate doldrums, trade winds, prevailing westerlies, polar easterlies, and jet streams. And we'll define those terms as we go along. Now let's go ahead and go to our first topic, and that's forming wind. Uneven heating of Earth's surface by the sun causes some areas to be warmer than others. Go back and think about Section 2 when we talked about how warmer air expands, becoming less dense than colder air. And if you look on slide 108, I have a visual representation for that. Well, let's continue on with our discussion of forming wind. Now, this causes air pressure to be generally lower where air is heated. Wind, let's not find what wind is. Wind is movement of air from an area of higher pressure to an area of lower pressure. That's the definition of wind. Now, let's go into a subcategory under forming wind, and that's heated air. Areas of Earth receive different amounts of radiation from the sun because Earth is curved. Now, if you look at the image on there, I just illustrated where the equator is, but if you look at the Earth, it's not, the shape of it is how it's shaped gives a curve, which means the sun hits on different points. Now, looking at the image on slide 110, you're going to see why the equator receives more radiation than areas to the north or south, and it's because the curving, that portion sticks out towards the sun, sticks out closer, so to speak. Now, the heated air at the equator is less dense, so it is displaced by denser, colder air, creating convection currents. All right. Now, this cold, denser air comes from the poles, which receives less radiation from the sun, making air at the poles much cooler. All right. The resulting dense, high-pressure air sinks and moves along Earth's surface. However, dense air sinking at less dense air rises does not explain everything about wind. So let's continue on and let's talk about another thing. This is called the Coriolis Effect. All right. Now, what would happen if you threw a ball to someone sitting directly across from you and you're on a moving merry-go-round? If you don't know what that is, if you look on slide 113, you can see this represented in the two images. Now, the question I want to ask you is, what would happen? And more specifically, would the ball go to your friend? Well, I had some videos, but I could not post them in the slide, but I'll try to post them later today, and they illustrate in a visual format of the Coriolis Effect. Now, let's just talk a little bit more about that. By the time the ball got to the opposite side, your friend would have moved, and the ball would appear to have curved, even though it didn't, but just based on the trajectory and how the shape and the movement. All right? Now, like the merry-go-round, the rotation of Earth causes moving air and water to appear to turn to the right, north of the equator, and to the left, south of the equator, and this is ultimately called the Coriolis Effect. Now, if you look at slide 116, you can see this visually represented on the two images, both on the bottom, on the left and right. Now, let's continue our discussion, just mention a little bit more about the Coriolis Effect. Now, the flow of air caused by differences in the amount of solar radiation received on Earth's surface and by the Coriolis Effect creates distinct, that means they're unique, distinct wind patterns on Earth's surface. Okay? These wind systems not only influence the weather, they also determine when and where ships and planes travel most efficiently. And so in the plane's navigation system, they account for this, so as they're traveling, since it knows it's going to move, they have to adjust accordingly, which is pretty cool. All right, so we're going to end up on today finishing up on slide 119 with a question. So we're going to talk about global winds, but we're going to start with a question. How did Christopher Columbus get from Spain to the Americas? Think about that. All right. This concludes today's lecture. If you have questions, leave them in the comments below. Please feel free to reach out to me, and I hope this helps. Take care. Goodbye.